No one expected this from Toyota. Not the analysts, not Detroit, not even the EV diehards who thought Toyota was years behind. But overnight, the world's biggest automaker just detonated the battery race. A real, road-ready, solid-state battery. Over 1,200 miles on a single charge. Full recharge in 5 minutes. No lithium crunch, no cobalt politics, zero compromise. And this isn't a dusty prototype locked in a research lab. It's already rolling out of Toyota's pilot lines in Aichi, Japan, prepped for mass production. The first model? A compact Toyota priced under $30,000, aimed straight at the heart of the global car market. Within 72 hours of the reveal, battery suppliers went into panic mode. Stock values for legacy automakers evaporated by billions. And the entire EV startup scene flattened, because this is more than range, it's more than speed. It's about control, owning the tech that can power cars, planes, homes, even entire cities, without the chains of lithium dependency. Solid state was supposed to be decades away. Toyota just dragged the future into the present, at scale. And in doing so, they may have rewritten the rules of the entire energy game. If you're ready to see how Toyota's breakthrough could reshape the future of energy, hit that like button, subscribe for more game-changing reveals, and tell us in the comments, has Toyota just pulled off the move that leaves every rival in the dust? For decades, the EV world was locked inside a lithium cage. Lithium-ion cells were the king of batteries. Powerful, yes, but also volatile, short-ranged, and painfully slow to recharge. And always, that lingering risk of thermal runaway, the polite industry term for, it might catch fire. The question was, never if someone would break free, but who? And no one, absolutely no one, thought it would be Toyota. No global countdown, no cinematic livestream, no stage lights. Just a closed-door engineering summit in Toyota City, attended only by top executives, select investors, and a handful of stunned engineers. What happened inside was nothing short of historic. Toyota confirmed that their solid-state battery program wasn't a far-off dream. It was real, fully functional, and already pushing boundaries once thought impossible. These cells have been tested relentlessly for over 18 months, integrated into prototype packs that shatter every performance benchmark in the EV playbook. The numbers? A verified 1,200 miles on a single charge. Recharge time? Less than 5 minutes. The same power unit that can take you from Tokyo to Fukuoka without stopping can refuel faster than it takes to pour a cup of green tea. Toyota didn't roll out a concept car that day. They rolled out something far more dangerous to their rivals. Proof that the lithium age is ending. On one leaked slide from the meeting, a single phrase in bold black letters sent shockwaves through the auto industry. Beyond lithium. This isn't just an upgrade. It's the start of a new battery era, one where Toyota holds the keys and the rest of the industry is suddenly racing to catch up. So why is Toyota's breakthrough sending shockwaves through the entire EV industry? First, they've removed the very flaw that has haunted lithium-ion batteries from day one, the flammable liquid electrolyte. Instead of a volatile, fire-prone liquid, Toyota's solid-state cells use a proprietary ceramic polymer matrix that's stable under extreme conditions, safe in collisions, and brutally efficient at moving energy. The leap in performance is staggering. Energy density has jumped from around 250 watt-hours per kilogram in today's best EV cells to nearly 450 watt-hours per kilogram, meaning almost double the power in the same footprint at a fraction of the weight. The result? Lighter cars, longer range, sharper handling, unmatched acceleration. These new Toyota cells are roughly 30% lighter and 15% smaller than the packs used in their current BZ series EVS. But it's not just about compactness. The solid-state design makes the battery pack rigid enough to serve as part of the vehicle's chassis, boosting crash safety and structural stability. Deep inside, a hidden advantage changes everything. A graphene-infused anode that virtually eliminates dendrites, the microscopic metal spikes that slowly kill traditional lithium-ion batteries and can trigger catastrophic short circuits. In Toyota's internal stress tests, these cells have survived more than 2,500 full charge-discharge cycles with less than 8% capacity loss. Translated into real-world terms, that's well over 1 million miles before you'd notice a serious dip in range. And here's the kicker: they run cool. Even under brutal high-speed charging or sustained high-load driving, pack temperatures stay stable, sidestepping the thermal runaway events that have plagued EV safety headlines for years. Toyota's breakthrough doesn't end with the battery itself, they've gone after the entire charging ecosystem. Meet Toyota's hypercharge of 5.5 system, a next-generation station capable of delivering a jaw-dropping 2.2 megawatts of power through an advanced liquid-cooled cable. This isn't fast charging anymore. This is industrial-grade energy transfer, the kind once reserved for power plants and heavy industry. With it, a Toyota solid-state EV can go from empty to full in under 5 minutes. No more coffee breaks disguised as charging stops. This is faster than filling a fuel tank and far cleaner. But here's the reality check: the global grid isn't built to handle sudden energy surges this extreme. Toyota's answer? Pair every hypercharge station with grid-independent storage banks, massive stationary solid-state packs that sip power slowly from the grid, then unleash it in an instant when a car plugs in. The result? No grid strain, no blackouts, and charging speeds that leave every competitor gasping. Safety, often the Achilles heel of high-performance batteries, has been turned into Toyota's secret weapon. These solid-state cells shrug off extreme conditions, from minus 30 degrees Celsius Siberian winters to 90 degrees Celsius desert heat, without swelling, leaking, or degradation. Puncture one, and instead of fire or explosion, it simply sits there, intact. Toyota has even crash-tested full prototype packs inside reinforced test vehicles, simulating worst-case collisions under Japan's strictest safety standards. The result? Over 90% less heat spread in fire simulations compared to conventional lithium-ion packs. In effect, the battery isn't just a power source, it's a structural shield, reinforcing the chassis and protecting occupants in ways no EV has done before. Toyota hasn't just built a battery, they've built an energy fortress on wheels, one that could redefine not just electric cars, but every battery-powered machine on the planet. This isn't marketing spin. Toyota's quiet revolution in its battery labs has already set the stage for a global shake-up that will hit automakers, energy giants, and raw material suppliers all at once. Their solid-state breakthrough kills range anxiety, erases long charging waits, and delivers safety standards most engineers thought were physically impossible. 1,000 miles, 5-minute recharge, a lighter, longer-lasting pack that refuses to catch fire even when abused. Toyota didn't just roll out a new battery, they triggered a new era. And the instant the news broke, even as whispers, the ripple became a tsunami. In Japan, Panasonic knew before anyone else. They weren't worried because they were already inside the operation. Weeks earlier, they had quietly joined Toyota in a joint pilot production line near Nagoya. This was no supplier-client handshake. It was an industrial alliance with stakes high enough to rewrite market share forecasts. In China, CATL, the battery colossus, went into emergency mode. Closed-door meetings ran into the night. Executives rushed to regulators, desperate to accelerate their solid-state roadmap. It wasn't about catching up anymore. It was about staying alive. In Detroit, GM quietly hit the brakes. Their Ultium platform, the cornerstone of their EV future, was suddenly under threat. Engineers were reassigned to tear down Toyota's ceramic electrolyte patents, searching for loopholes. Every diagram, every projection was back under review. And in Wolfsburg, Volkswagen's much-hyped battery schedule looked suddenly primitive, a relic from another age. Within 48 hours, analyst reports flipped from bullish to panicked. The EV tech gap between Toyota and the rest wasn't 2 years anymore. It was 6, maybe 7. And even that sounded generous, because unlike everyone else, Toyota wasn't talking about what they planned to do. They were already doing it. While rivals were still polishing their press releases, Toyota was gathering proof. Not in sterile labs, not in carefully controlled simulations, but on the road, in motion, across the world. 50 prototype Toyota vehicles, each armed with solid-state battery packs, have been quietly circulating through Japan, North America, Europe, and even the icy backroads of Hokkaido. These aren't concept cars or PR darlings. They're stealth test units hidden in plain sight under commercial NDAs, disguised as ordinary production models. But under the skin? The future is already here. These vehicles aren't just clocking miles. They're enduring searing desert heat, sub-zero mountain passes, rapid-fire fast charging, and months of stop-and-go urban abuse, stress tests designed to break weaker batteries in weeks. The early data? Devastating to the competition. Average real-world range, 958 miles per charge across mixed driving conditions, without a single pit stop for charging. And Toyota isn't locking this away. They've already set a public data release for early next year. If the official numbers match what's being seen internally, it won't just make headlines, it will force a reckoning across the auto and energy sectors. Because real-world validation is the milestone no other company has reached. Toyota just drove right past it. But this isn't just about cars. Toyota didn't pioneer hybrid technology decades ago just to build better sedans. They did it to change how the world uses energy. Now, that mission is scaling far beyond roads. By 2026, Toyota plans to integrate solid-state cells into its home and grid storage systems, from compact residential units to industrial-scale battery farms. These next-gen storage packs will be lighter, cooler, and stackable, cutting installation costs by nearly 20% while doubling service life. For homeowners, that means a solar-powered house that once stored energy for a single day can now keep the lights on for almost 2 without bulky add-ons or costly infrastructure. And in the farthest reaches of the planet, from Alaska's frozen villages to island communities in the Pacific, Toyota's new solid-state storage banks will enable 100% renewable, off-grid living, recharging in under 2 hours from direct solar. This isn't a pitch deck, it's already breaking ground. These aren't just home upgrades, they're energy liberation systems built for the farthest edges of civilization. And they run on the exact same solid-state platform driving Toyota's next generation of vehicles. Toyota's automotive division and energy division, now powered by the same core technology. And here's the market shocker. This battery doesn't just perform better, it's engineered smarter from the ground up. Toyota's solid-state chemistry uses zero cobalt, zero nickel, and less than 5% lithium by mass. That instantly diffuses the geopolitical minefield surrounding rare mineral supply chains. The ceramic electrolyte, a proprietary lithium phosphate oxide blend, is non-toxic, inert, and fully compatible with Toyota's existing high-volume battery lines. No need for billion-dollar retooling, just new materials in proven machinery. And those materials? They come almost entirely from domestic and allied sources. No cobalt from the Congo, no nickel from Indonesia, no rare earth dependencies from overseas. To close the loop even tighter, Toyota has constructed a new anode production facility in Aichi. This cuts shipping costs by over 40% and wipes out months of potential delays from global freight congestion. Analysts are calling this vertical integration on overdrive, not just batteries built in Japan, but an entire energy ecosystem grown from the ground up on home soil. By 2027, Toyota aims to produce 80% of all solid-state components in-house, making them the most secure and scalable battery producer in the developed world. If they hit that milestone, Toyota won't just be an automaker, they'll be a sovereign energy powerhouse. And they're not just talking about it. While competitors were still drafting strategy memos, Toyota was already running ceramic cells through production at scale. 2 solid-state pilot lines in their Motomachi plant are already live, fully automated, astonishingly efficient, with an initial capacity of 250,000 packs a year. Not concepts, not prototypes. Full packs, ready for vehicles. Their internal yield rate? 91%, where most rivals can't break 70%. That's not lab grade, that's production grade. Automation is the secret weapon. Robotic handling of ceramic electrolyte sheets, zero moisture exposure, sealed assembly lines run by AI-driven quality control. Labor costs are down 60% per pack. Speed has doubled. Human error? Eliminated. And Japan is just the beginning. The next frontier is Toyota's new battery gigafactory in Thailand, purpose-built from day one for solid-state-only production. No legacy lithium-ion lines, no hybrid systems. Pure, clean sheet design for the battery age that's replacing the one we've known for 30 years. By 2026, that plant will roll out the first Toyota with 100% ceramic solid-state architecture, a vehicle that already has a name inside company walls, and a launch date circled on the calendar. Codenamed Toyota X1, it's not just another electric SUV, it's the first ground-up 100% solid-state Toyota in history, and it doesn't just break the rules, it rewrites them. Over 1,200 miles of real-world range. 5 minutes to a full charge, a starting price under $30,000 US. That's not evolution. That's the quiet extinction of the combustion engine. The X1 uses Toyota's revolutionary cell-to-frame integration, turning the solid-state pack into the vehicle's structural core. No dead weight, no excess metal. The entire platform is 28% lighter than the RAV4, yet stronger, stiffer, and safer. And because it was designed for high-volume production from day one, Toyota expects the X1 to become its best-selling vehicle ever, eclipsing even the Corolla. While Toyota surged ahead, much of the industry froze. Legacy automakers, who invested billions in lithium-ion, suddenly found themselves holding yesterday's technology. Factories optimized for old chemistry now looked like stranded assets. Joint ventures were re-evaluated. Expansion plans were shelved. Battery giants like CATL, LG, and SK On scrambled to open talks with Toyota over licensing its proprietary ceramic electrolyte patents. The same chemistry critics once said could never be stable at scale. Now they wanted in. And the price tag for entry? Industry whispers put it at over $4 billion for a basic licensing agreement. Then came the market shock. In just 3 trading days, more than $46 billion was wiped from the valuation of legacy EV and battery stocks. Startups touting next-gen chemistries, silicon anode, sodium ion, lithium air, saw their investor interest evaporate overnight. One analyst summed it up in 6 words. This isn't competition anymore, it's consolidation. Toyota's leadership, usually measured in its statements, issued one simple line that echoed through investor calls and news headlines. We didn't improve the car, we ended the compromise. And that's exactly what this is. Charging stations? Less critical when you can recharge in 5 minutes. Battery degradation? Virtually eliminated. Cobalt mining controversies? Gone. 4-continent supply chains replaced with domestic production powered by renewables. Toyota hasn't just redefined the battery, it has reshaped the economics of mobility. It collapsed timelines, shattered forecasts, and bypassed the 5-year technology gap the industry thought was unbreakable. And the X-1 is only the beginning. By 2026, Toyota's solid-state technology will extend far beyond cars, into residential Powerwalls, grid-scale megapacks, and even aerospace platforms. Imagine an off-grid village in Hokkaido, running for days on stored solar power. Imagine container ships crossing oceans without a drop of fuel. Imagine electric aircraft with ranges once thought impossible. This isn't theory, it's already under test. Insiders hint that Toyota's aerospace division is evaluating ceramic cell derivatives for next-gen drones and high-altitude aircraft, where weight-to-energy ratio is the ultimate bottleneck. All of this began with a single decision, to throw out the old roadmap and build the future 10 years ahead of schedule. The auto industry is no longer just about horsepower or design. It's about storage density, charge speed, and grid integration. Whoever owns the battery owns the future. Right now, Toyota isn't just in the race, it's running alone. The era of lithium is over. The age of solid state has begun. And for Toyota, this isn't following a trend. It's writing the next chapter of mobility itself. If you thought this was wild, you haven't seen anything yet. Toyota's just getting started, and so are we. Hit that like button, smash subscribe, and ring the bell so you don't miss the next chapter in the revolution. The road ahead is changing fast, and you'll want a front row seat.